Study section 7. The ear. Introduction. The ear is the organ of hearing, and it is essentially response to sounds. Hearing is the sense that allows members of our sociable species to communicate in hearing and interpreting speech. Hearing also gives us other information about the world that is vital to our survival. Like vision, it is a multi-level system with primary receptors, intermediate level relays, a primary cortical representation, and many higher integrative areas as well. The sense of audition or hearing helps us to identify objects in the environment and to determine where objects are in relation to our bodies. Objectives. At the end of this lecture, you should be able to 1. Explain auditory perception, and 2. List and discuss hearing disorders. Content. Sound begins with the movement of an object in space for humans. The medium that carries sounds is usually the air, but we can also perceive the sound that travels through liquid and solids. Like light, sound interacts with the environment as it travels from a source to the perceivers. Fabric absorbs sound waves and can be helpful in reducing sounds. The height or amplitude of the wave indicates the intensity of a sound. Low amplitude waves are characteristics of soft sounds, and high amplitude waves are perceived as loud. The frequency of the wave or the number of circles per unit of time indicates wavelengths. Wavelengths usually time corresponds to the perceived pitch of a sound. Long wavelengths are perceived as having low pitch, whereas short wavelengths produce sounds with higher pitch. The simplest type of wave sound is a pure tone, which has a single frequency. Most sounds consist of combinations of waves. Waves that do not regularly repeat themselves are perceived as noise, as opposed to identifiable tones. Sound intensity is measured in units called decibels, dB. While a whisper is about 30 decibels, a live band blasts about 710 decibels. The higher the decimal level, the more intense the sound and the greater the danger of damaging the organ of hearing. This is why people who work near noisy equipment are always advised to wear ear protecting equipment. The unit used to measure the frequency of sound is the Hertz, Hz. A 500 Hz sound completes 500 circles in 1 second. Speech and music are made up of complex combination of frequencies. The structure and function of the auditory system. The structure of the human ear. The components that make up the ear are generally divided into 3 parts: the outer, the middle, and the inner ear. Each part of the ear serves specific purpose in the task of detecting and interpreting sound. The outer ear. The outer ear consists of the structure visible outside the body, such as the pinna. Pinna. The pinna is the visible part of the outer ear. The pinna serves to collect and focus sounds just like a funnel. The pinna also plays an important role in locating the source of sound. Movement of the pinna allows some species to further localize sounds or to indicate emotional states, as when a dog puts its ear back while snarling. Sounds collected by the pinna is formed primarily of cartilage and is attached to the head by muscles and ligaments. The deep central portion of the pinna is called concha, which leads into the external auditory canal, which in turn leads to the tympanic membrane. The tympanic membrane or eardrum forms the boundary between the outer ear and middle ear. The boundary between the middle ear and the outer ear is formed by another membrane, the oval window. The middle ear is an air-filled cavity which contains three interlocking bones called the ossicle. These are the smallest bones in the body. Each of the tiny bones is about the size of a single letter of print in this text. The purpose of this bone is to transfer sound energy from the outside ear to the fluid in the inner ear without losing acoustic energy. The bones are called the malleus, Latin for armor, the incus, anvi, and the stapes, stirrup. The ossicle attached to the tympanic membrane is the malleus, which form a rigid connection with the incus. The incus forms a flexible connection with the shapes. The flat bottom of the stapes, the foot plate, is connected to the oval window, a second membrane covering a hole in the bone of the skull. The middle ear solves the transfer problem in two ways. First, the connection between the ossicles are inked, and this creates a lever action that increases the force of the vibration that the stapes bone delivers to the oval window. Second, force applied to the much smaller oval window produces much more pressure than the same force applied to the large tympanic membrane. With both force and pressure increase at the oval window and pressure increase at the oval window, the air can recover about 23 dB of the 30 dB that would otherwise be lost when sound is transferred from the air in the middle ear to the fluid in the inner ear. The movement of the tympanic membrane and the ossicle is restricted by two small muscles, the tensor tympani and the stapedius. When the auditory system is subjected to very loud sounds that are potentially harmful to the inner ear, the two sets of muscles, the tensor tympani and the stapedius muscle, contract, and in so doing reduce the magnitude of the vibrations transmitted through the middle ear. The responses of these muscles to loud noises are known as the acoustic or middle ear reflex. The inner ear. The inner ear contains two sets of fluid-filled cavity embedded in the temporal bone of the skull. One set is known as the semicircular canal, and the other is known as the cochlea, snail in Greek. The balanced portion of inner ear consists of three semicircular canals and the vestibule. The inner ear is encased in the hardest bone of the body. Within this ivory hard bone, there are fluid hollows. Within the cochlea are three fluid-filled spaces: the tympanic canal, the vestibular canal, and the middle canal. The 8 cranial nerves comes from the brain stem to enter the inner ear. When sound strikes the eardrum, the movement is transferred to the foot plate of the stapes, which presses into one of the fluid-filled dots of the cochlea. The fluid inside this dot is moved to flow against the receptor cells of the organ of Corti, which fire. This stimulates the spiral ganglion, which sends information through the auditory portion of the 8th cranial nerve to the brain. The organ of Corti is a structure within the cochlear dot responsible for translating vibrations in the inner ear into neural messages. Hair cells are also the receptor cells involved in balance. Although the cells of the auditory and vestibular systems of the ear are not identical, vestibular ear cells are stimulated by movement of fluid in the semicircular canal, and the utricle and sulcle. Firing of the vestibular ear cells stimulates the vestibular portion of the 8th cranial nerve. Auditory perception. Perception of pitch. Normally, we associate pitch, the high or low quality of a sound, with frequency. But pitch can also vary due to other factors other than frequency, such as the intensity or context. Pitch helps us to distinguish between low and high sounds. Pitch depends on the frequency of a sound wave. Frequency is the number of wavelengths that fit into 1 unit of time. Frequencies are measured in hertz. High sounds time have high frequency, and then loud sounds have low frequencies. Loudness perception. Our ability to detect loudness or intensity varies with the frequency of a sound. Auditory neurons can respond to higher levels of intensities by increasing their rate of response. Localization of sound. Our primary means of localizing sounds in the horizontal plane, in front, behind, and to the side, is a comparison of the arrival times of sounds at each ear. The differences in arrival time are quite small, between 0 ms for sounds that are either straight ahead or behind you to 0.6 ms for sounds coming from a point perpendicular to your head or either side, because arrival times from sounds immediately in front or behind you are identical. These sounds are very difficult to localize accurately. Distinction between arrival times of sounds at each ear are made by neurons in the superior olive. These neurons are known as binaural neurons because they receive input from both ears. The human ear is able to hear frequencies if 20 to 20,000 Hz. Thunder has a frequency of only 50 Hz, while a whistle can have a frequency of 1000 Hz. Intensity. Hearing loss arises from a wide variety of cases and affects nearly 20 million of Americans. Sekula and Blake, 2002. A person is considered legally deaf when speech sound of 82 dB or less cannot be heard. Age-related hearing loss may result from a variety of factors, including poor circulation to the inner ear or the cumulative effect of a lifetime of exposure to loud noise. Hearing loss resulting from problems in the outer or middle ear is referred to as conduction loss. Conduction loss may result from a build-up of wax in the hair canal, infection of the middle ear, and a disease known as otosclerosis. People with conduction loss can be helped by use of a hearing aid, which acts by amplifying sound signals. Hearing loss may occur due to damage to the inner ear, the auditory pathways, or the auditory cortex. Some substances such as quinine and antibiotics damage ear cells in sensitive individuals. Nicotine produces hearing loss by reducing blood supply to the ear. Selman, 1973. End of study section 7. Thanks for listening.